So today we're here to learn about how we write Ansible modules in PowerShell. Before I start, just like to give a thanks to our sponsors. I'm sure many of you have been to their booths that we've had here. If not, really have a look at them. They're really great people. The products that they help sell are fantastic. So without them, we wouldn't be here, and that's just a fantastic thing. So my name is Jordan Borean. I'm a software engineer and I work for Red Hat. More specifically, I work on Ansible and I specialize on the sort of Windows integrations, so dealing with the PowerShell modules and the content that we create for it, as well as how Ansible actually interacts with Windows hosts, so the connection stuff and everything like that. I enjoy working with Python. It's what I get paid to do, so that's always a big positive. But on the side, I like working with PowerShell and C#, and really just interacting with the community is where I've sort of been able to enhance my skills there and sort of get to where I am today. And it's just a fantastic language, fantastic community, and I just love working in that area. I like to go on a bike ride. Hopefully a lot of us sort of was there on Monday afternoon. That was fantastic. And I also just like learning new things as I go along. So either new technologies, new topics, just love to learn. I know this is a controversial thing. Unlike Jeffrey Snover, I really dislike aliases in scripts. I know he's a proponent of it, but it's not really something that I really enjoy. I think they're a mistake to use, and I'm sure people have different opinions there. So because this is a follow-along session that we have here, I've got a link and a QR code that you can follow along. This will bring you to a Google Docs page where you can put your name against a table where there's an IP address and a password, and you can use this Windows host as your sort of test VM as you're following along. I have a Windows host as well. There's probably about 35 to 40 instances on that page, and hopefully that will cover everybody that wants to use it. If there isn't, please either put up your hand, put your name on the bottom of the sheet, and I'll be able to spin up some more. Probably take about 5-ish minutes for that to actually be ready. So the page that you can see here, hopefully everybody should have editable access to put their stuff there. You have the IP address on the left-hand side of the actual VM itself. You have the password for it, and the username is just Ansible. There's also a link here that links to a GitHub README that has the steps as I'm following along. It's probably not the easiest thing to follow. I haven't been able to sort of refine it as I go along, but that will have all the things that I'm doing, some of the background info that I'll definitely be talking about as I go along there. So that's very useful to see some of the commands that I'm running if you need to either copy and paste, see reference designs, or anything like that. Cool. So I see people signing up. There's a few ones in there. If it does run out, once again, put up your hands and I'll be able to sort of spin up some more and get that all ready for you, for everyone. That's the link there. So bit.ly and then PSConfEU. It should be hopefully fairly easy. Just make sure everybody's got their phones down before I turn it away. Hopefully lost one there. Awesome. Fantastic. 3, 2, 1. Cool. So what is Ansible? This is a straight rip and paste, copy and paste straight from the Ansible.com website. Essentially, I can repeat this if I really want to, but it's always nice to say what I think Ansible is. I find that Ansible is a fantastic configuration and orchestration management tool. So you can use that to do a whole bunch of things. You can use it to provision infrastructure, deploy applications on servers. You can even use it to manage networking devices, Linux machines, Windows. We also support BSD, and I think there's a few brave souls trying to deal with mainframes and ZOS. So we've got a wide range of different applications for Ansible, and you can all do that inside the same playbooks and sort of touch them all at the same time. So it's really fantastic if you're working with multiple hosts, multiple machines, and working them together. Ansible has its core engine, but one of the key components that we have here is our plugin system. Basically, the plugin system is a way of extending the functionality of Ansible. We have so many different types of plugin types, which I'll show you in the next slide here. Essentially, every single plugin type, except for modules, have to be written in Python. That's because they are part of the actual Ansible process itself, which is running with Python itself. We have a few built-in plugins that you can actually use. So sort of very basic things like sort of testing the connection, creating files and things like that. But we're trying to move away from sort of the batteries included model into a more distributed one where people can pull in the content that they need. So similar to PowerShell, where you have the sort of built-in commandlets and the core functionality, but then you have a whole wide range of modules that are available through the PowerShell gallery. So hopefully this isn't too small. This is a mock-up that I made probably 6 or 7 years ago of sort of the various different plugins. You can see all the boxes in yellow. They're all the different plugin types that we have. Today, we're really going to be focusing on that bottom right-hand corner, which is the sort of modules, basically the plugins that are running on the remote host itself, which on Windows, we use PowerShell for the actual language itself. We'll briefly touch on action plugins as well as module utils, but that's sort of just a further reading type of thing. So I'll go over them, but I won't go over them in depth like modules. Before I also get started as well, I like to sort of briefly introduce the concept of roles and collections. So these are essentially the modules of Ansible. So with PowerShell, you can install modules that extend the functionality and provide new commandlets. With roles and collections, you can do the exact same thing. So people can create their own collections to produce their own modules, action plugins, all the things that you like. And essentially, it was a new concept introduced in Ansible 2.9, which I know it sounds weird saying this, but it's probably about 6 or 7 years ago, and that's just crazy to me. But essentially, it's all managed through the Ansible Galaxy command, which is part of Ansible itself. Modules, they're executed on the target host. So when Ansible actually tries to run a task, it creates a connection to the remote host. Typically for Linux, we're using SSH. For Windows, we have WinRM. You can use SSH for Windows as well, and a few other ones that are out there. Essentially, it ships the code off to the remote machine. It starts up PowerShell, and then it will run that module itself. For Linux and Mac OS, we typically write them in Python, and then Windows, we write them in PowerShell. But in reality, you can actually write them in any language that you like. So if you're really a Bash fan, you can write modules in Bash. If you love Ruby, you can do that in Ruby. We even support compiled binaries. So if you really like C, go for gold. But typically, you really just want to aim for the Python and the PowerShell side because you get the most functionality and the extra features for that one there. When you create a module, you typically use that to focus on one resource in particular, and you manage that resource in an idempotent fashion. I know that's a sort of a bit of a buzzword, but essentially with idempotency, you're able to sort of declare the state that you want that resource to be in, and that will go through the actions of figuring out how do I actually get there. So whether it actually needs to make a change or not, and sort of deal with other things like prerequisites and things like that. So that's sort of the brief spiel of Ansible. Let's sort of get into the demo itself. So hopefully we have a Windows host that everybody's sort of connected to. If you don't want to use this VM, you can use your own Windows host, but you do need WSL to run Ansible on. So that's what this sort of VM is actually for. But it's up to you if you want to follow along or just watch as I'm going along here. So the first thing that we need to do is we need to configure our host to actually run Ansible. We have sort of a few brief steps that we have here. We want to install Chocolatey, which is a fantastic tool. To also install Visual Studio, which we'll use as sort of our debugger or our IDE when we're working with the playbooks. We'll also install WSL and set a few different things. What I'll do is that I will copy this code. I'll go to my Windows host and I'll start installing that because this can take 1 or 2 minutes as it goes along. I'll make the font bigger as well to make it easier for people to see. So the other reason that we're using Chocolatey here is that I didn't want to have to deal with getting the VS Code installer and dealing with the arguments. That will just install everything for me. But then we're also going to install WSL using the WSL command. We're also going to do one extra step, which is to configure the local account token filter policy. This is only required right now because we're going to be testing with a local account. And when you do a network login with a Windows host, it needs to be running as administrator for WinRM to actually work. The policy that this is going to configure, if I go back to the actual code itself, so we have a registry path and then the registry property, which we're setting. This basically tells Windows is that when a local account connects through a network login, don't filter this token, give them the full admin token. So that's sort of a requirement because we're going to be doing admin work with this one here. And there's no way of calling UAC inside a network login. So this is required. Finally, we're also going to reboot the computer as well. That's basically because WSL itself requires the reboot after installing the features. It has all sort of the Hyper-V configuration and everything else like that. So as it's going along here, hopefully it shouldn't be too much longer as it's installing. It should give me the opportunity to reboot it. While it's doing this one here, I just want to take a quick pause to make sure that everybody's all good with the machines that they're following along with and everything's all fine. So that link that's in that Google Doc page, so this one here at the top, the README, that one there will link you to the README, which is this page here that I've been following along. So hopefully that will give you the codes that you can use to run there. Yeah, sorry. Cool, so it's configured everything. We want to restart the computer because that's going to take a minute or two for it to come back online. That's going to boot me off. While I'm waiting for that one there. Once it comes back from the reboot, I'll talk you through the commands that we're running here. Make this a tiny bit bigger as well. So we can see here that we've got a few commands that are running on Bash, mainly because that's running on the Ubuntu image that this will set up for us. Essentially, we're going to update the cache to make sure that we have the latest feeds and everything on there. We're going to be installing Git as well as a few Python packages. Git's just required so we can actually download this repo locally, so we can also follow along on that one there. And then we're also going to be installing those various Python packages. So we have Python 3, Python 3 pip, and Python 3 VM. With Ubuntu and Debian-based distributions, they like to split up the various components together. Usually that's all part of the one Python umbrella, but we just want all three packages so we can install Ansible through pip, and we can also use VM to create what we call a Python virtual environment. There are many ways of installing Ansible. You can install it through the actual system packages, through apt, DNF, whatever you like. You can install it directly from source. It's just a Python library that we do on there. My personal favorite, mainly because I'm a developer, is to use these virtual environments. It allows me to have multiple versions installed in the various different environments, and I'm not tied or restricted to the versions that the distribution might actually ship with. So hopefully, as I've been talking to that one there, we can try and reconnect to our host. Just ignore the certificate because we're using an IP address. So it's going to log into the host again. The first thing that's going to pop up here, hopefully is not the server manager, which it is. I forgot to disable it. But once that one there loads, it's also going to bring up the sort of initialization script or the initialization console with WSL. That's going to do the sort of the last remaining configuration steps that we have on here. I'll make this a bit bigger so it's easy to see. So it's just going to download the Ubuntu image. With WSL, you can install whatever Python distribution that you want, but usually Ubuntu is sort of the default or the easiest one that people sort of going into Linux for. I'm not too sure, I can't remember if I mentioned it, but the reason that we're doing this is that Ansible has to run on a non-Windows host. So the main controller components need to run on either Linux, Mac OS. I think there's a few people running it on BSD, some brave souls. But essentially it uses a whole bunch of API calls that are not available on Windows, which isn't fun if you're using that as your sort of main development box. But if you've got WSL, either version 1 or version 2, it's a really convenient and easy way to actually run Ansible on your host on the Windows machine that you're working for. So this is a fantastic tool for people to actually use. Once it has installed, we should get the next prompt, which will ask us to configure our Linux username and password that we actually want to log in as. In this case here, you can technically set it to whatever you want, but this guide is geared towards setting the username just to Ansible, and then the password can be anything that we want. I'm probably going to be doing the very secure and very secret way of actually setting the password to Ansible as well. I'll close down a server manager so that doesn't bother us as well. I don't need that one anymore. Hopefully this one here will take a few more seconds. There we are. So we'll enter in the username, which is just Ansible, and then we'll put in our password, also Ansible, and retype it in there. So we have our installation is all successful and ready to go. We've logged into the actual WSL host and we're running it as our Ansible user. So the first command that we're going to be running is our sudo apt-get update. So as I mentioned before, this sort of updates the feeds to make sure that we're getting sort of the latest URLs and the latest packages that are actually available from apt-get. That's going to take just a few seconds. Once that one runs, we're going to be running this command here to install Git, the Python packages, as well as sort of the VM type stuff. So I'm going to be lazy and just copy and paste. That doesn't work, so I'm not going to be lazy. -y, we have Git, Python 3 pip, and Python 3 VM. So that's going to pull down those packages. Usually they're pre-compiled, and these packages here, because it's coming through the system package manager, they're already pre-vetted by the distribution that you're working on. So that's one of the reasons some people do prefer to install Ansible through this particular method here. You do get that sort of extra stability and maybe sort of that a bit more of a security guarantee. But if you're sort of doing development, that's where I sort of err on sort of the virtual environment one, which I'll show you as we're going along here. So that will take a few, or hopefully 1 minute to install. If we go back to our code, the next step that we have here is this Python command. So Python 3 -m VM and then a path. So Python 3, of course, is calling the binary. -m is an argument to run this particular module. In this case here, we have the VM module, and that just takes a simple path to create that virtual environment app. What this is it's essentially creating what we similar to a PS module path folder with a whole bunch of sort of scripts and isolated environment variables that we can use to install Python packages. So if we go back to our host, you can see it's still chugging along as it's installing on there. Hopefully it shouldn't take too much longer. So we have the empty prompt ready for us to start on. So we will call Python 3 -VM and then the path. That should take only a few seconds. Once we've created the virtual environment, we also need to activate the environment. So in this case here, we do source, which is sort of a bash command to source the file, similar to .sourcing. Then we type in the path, and then inside the bin folder, there's an activate script. So if we run this one here, we can see that our prompt has changed and we have that Ansible VM in the brackets to tell us that we're in there. And then that's the environment that we're in. From there, the next step that we want to do, I believe, is to download or git clone our repository. We'll also cd into that location as well. So this is that repository that I've linked to inside that Google document. It has sort of all the README as well as sort of the basic framework that we have with the collection and the other stuff that we'll be learning about as well. So we have a virtual environment. We now need to install Ansible. So if I do pip install, pip is the Python package manager, so similar to install module that we have, or install PS resource now. I want to do -r, which is a requirements file, and then I'm just calling it requirements.txt. This is going to go through the lines inside that file there to install the packages. In this case here, I have Ansible core, all its dependencies that are there, the PyPSRP module, which allows us to actually connect to Windows using the WinRM protocol, and then also another one which we'll use later on in our action plugin example. Just to show you that file, it's a simple text file. So 3 lines that are in there. Ansible core is the Ansible package. PyPSRP is that WinRM PowerShell remoting one. Then SMB protocol is that extra one that we have on there. Finally, we're also going to be installing a collection. So this collection here is the Ansible.Windows collection. This is sort of the base Windows collection that we have with a few different modules like creating files, our WinPing modules sort of to test the connectivity. Usually when you're dealing with Windows, you want this collection here. So to deal with that, we have Ansible Galaxy collection install, then the name of the collection, so Ansible.Windows. Normally you can just run this one here and it will install it in sort of your user directory, similar to install module or install PS resource. But for this particular example, we want to install it to a collection adjacent, sorry, a playbook adjacent directory. So we'll do -p for the path and then collections. So that's going to fetch the collection from our sort of artifact repository, which we call Galaxy, also known as Automation Hub for the paying customers. And that's going to download that and install that collection inside this particular directory. Finally, the next step that we want to do is we just want to make sure that Ansible is actually installed and all working. We can just do Ansible -- version. This case here, it's just a whole bunch of output. We have the Ansible version at the top there, and a few other information that may or may not be relevant for what we're looking for. So we've set up Ansible. The next step is to configure our Windows host to be able to accept a connection from WinRM. In this case here, we're going to do 3 things. We're going to create a local user for us to target. We can theoretically use the same user that we've logged in as, but in this case here, I'm just going to sort of separate it to keep things different. We're going to be running enable PS remoting with force. That will register the PS remoting configuration sessions as well as sort of set up the WinRM service. I believe it also enables a firewall rule for the local subnet, so sort of your private or domain profiles. Because we're running on local hosts, that doesn't matter as much. And then we're also going to be doing 2 other things here to enable the SMB firewall for a later test, and installing the PS resource get module, which is sort of the new one from PowerShell. So I'll copy this script here. I will need to open a PowerShell prompt. I will paste this in. Everything's working. So this will just take a few seconds for this to actually configure the service as well as register the PS session configuration for PowerShell remoting. And then we have the WinRM E config listener. That will enumerate, so E just stands for enumerate the various listeners for WinRM. In this case here, we have our HTTP listener on port 5985. So that just tells us that we have a listener ready and we're ready to go. I'll accept this prompt here for NuGet. And the reason that we're installing the PS resource module is that our demo here is actually going to be about creating a module to manage PS resource repositories. It's a fairly new module from PowerShell, so we don't actually have a built-in module for this one here. I thought it was a good demo. It's a fairly simple one to sort of demonstrate how we can actually do that. So as it's enabling the firewall rule, while that's working in the background, we'll now test Ansible to make sure that we can actually connect back to our Windows host. So we'll open up Visual Studio. So Visual Studio Code, they are 2 different products. I will maximize it to make it easy to see. Also increase the font size. And I didn't want the high contrast theme, that is not for me. Let's go to dark. I'm curious, a show of hands, who actually uses a light theme here? Okay. Because of that, because I've been told, let's change it to a light theme so we can actually see it a lot better. Hopefully that's great for everybody here. Or is it too blinding from last night? Cool. All right, so what we want to do is we want to install the WSL extension. This extension here will allow us to actually connect our Visual Studio Code instance to our WSL VM that's running on this Windows host here as it's sort of running locally. There's various other ones from VS Code. So there's SSH, which is fantastic if you're dealing with remote debugging. There's also a Docker one if you're dealing with sort of containers on there. We also want to install the PowerShell extension. This isn't required, but it's sort of a nice to have, well, actually will be required in the upcoming steps when we're dealing with sort of debugging PowerShell modules. So we can close this one down here. Close that, close that. Then now that we have the WSL extension installed, we want to press F1 to open up the sort of run this command. We want to type in WSL to connect to the WSL host. What that's going to do, it's going to reopen Visual Studio. It's going to install the various VS Code server components on our WSL instance, and then it's going to be ready for us to do what we want to do on the actual WSL instance. So after it's unpacked, it should tell us that we're ready to go. We just have that opening prompt at the bottom here, and everything's all ready to go. So we can click on the File Explorer. We want to open a folder. We want to open up that folder that we cloned, so PSConfEU 2024. But we also want to open up this Ansible module dev folder inside that. That's what we're going to be working with today. If you trust me, you want to trust this author here. I'm very trustworthy, so don't worry, I'm not doing anything wrong with that one there. I'm just going to ignore this Git message because we don't have to worry about any of that here. And we're going to open up our README and we're going to continue along here as we're working through this actual code itself. So we have WSL set up on our machine. We have WinRM configured. We have our local user set up, and we're also connecting on this Ansible instance on our WSL instance here. So the final step that we need to do is we need to configure our inventory. So this is a particular file that Ansible will use to know what host to actually connect to, what's the IP address or the host name, as well as other connection info like the username and password. So we want to open up a terminal. In this case here, we just press Control Shift, then the backtick. Otherwise, you can go inside this top part here under the terminal one and click on New Terminal. From there, we also need to activate our virtual environment because this is a new shell. So we just want to go source, Ansible VM, bin, and activate. We can verify that everything has been working on that one there. So we can run Ansible, we get that output ready for us. So we've got a directory. We're in that directory that we need. So the Ansible module dev one. We've got our terminal open. And then what we finally need to do is we need to complete our template directory. So this is sort of a brief one that we have here, calling it inventory, just no extension. You can do .ini, but we're just calling it inventory today. We're going to change out this template hostname variable with what our Windows host is, with WSL to talk back to our, I believe this is for 2, I don't believe 1 is the same, but to talk back to our Windows host rather than our Linux WSL instance, we need to get the host name of our host. So we're running the hostname command and add .local onto the end there. So this sed command is just going to replace the hostname value with that one there that's unique to your instance itself. We've already activated the environment. And then finally here, we're going to be running this command. So Ansible, which is sort of what we call our ad hoc tasks. You can run individual modules with arguments that you provide on there. We'll specify the Windows group. That's part of our inventory. So that defines the hosts that we want to talk to. We're also setting this playbook dir argument. That's specifically because we've installed this Ansible.Windows collection adjacent to a playbook. With Ansible, there is no playbook, so you'll see that a few times on there. Typically, you don't need it, but we just do for this case here. Then finally, the module that we're running. So Ansible.Windows.WinPing. That's not doing an ICMP ping. It's actually going to connect to the host and try and run a very basic module to verify that everything's working on here. So fingers crossed with the demo gods, this is going to work first time. We see that we get the output there. So green, success, and then sort of just other generic data that we have back on there. So before I continue on, is there anybody that needs me to repeat any of the steps or are having any troubles with the stuff that they're on there? All good? Fantastic. So that was a very long-winded explanation about sort of setting everything up as we're going along here. Now let's get into the actual nitty-gritty of creating our modules and starting to learn how to structure these things, how are they written, how do they actually work inside Ansible. So the first one that we have here, we have a very basic example, so one_simple. If I was to run this one here instead of win.ping, we'll see that we get a changed key returned. We have key with some return value string, and then message is set to foo. If we open up that particular module, which is inside our collection, so we have our collections folder, we have PowerShell conference, we have plugins and the various different plugins that are on there. Then finally, we have modules, which has a whole bunch of modules that we'll go through as we're working on here. In this case here, we're very interested in the simple one. So you can see it's a very, very basic 2-line PowerShell script. We have our shebang at the top of there, so just hash exclamation PowerShell. That's a unique identifier in Ansible to say this is a PowerShell module, use the PowerShell runner for it. Finally, we also have a string that's a JSON string inside it, so we're sort of just manually outputting that one there with our changed key, our message foo, and then the key is the some return value. So this is very, very basic. Essentially, when Ansible runs a PowerShell module, it will send the arguments to it as a JSON file. The module will read it, and then it will output JSON again as a string back to Ansible to pass. So it's just sort of one thing in, JSON coming out. So we've done that very basic one. What happens if you want to provide options to a module? So in this case here, we're running the same thing, just the 2_args, but we're also specifying this -a with foo equals bar. So if I was to run this one here, what the -a is doing is it's setting module arguments. In this case here, we're setting the foo option to the bar value. So we see that we get this information back and test has the bar output. If I scroll back up to the 2_args module, we can see that it's probably a bit more complex. So we have a few more comments at the top part here. PowerShell common and want JSON. That's sort of like an older legacy way of declaring that I can accept JSON input arguments and to run it in the normal sort of PowerShell module way. So it allows us to get that input data. When Ansible sees that, it's going to set the global variable complex args to a hash table that includes all that information. In this case here, we're just setting it to another variable, but you don't have to do that if you want to. You'll note that this here uses snake case. That's essentially a Python heritage that we have on there. You can use snake case if you want, but I know some people really like their camel case. That's what we'll continue to use here. You can see that the result that we get back here, we're defining a hash table. This one here defines the change key, set it to foo. It's also setting test to the value of that foo input value. So that's how you can see that we're getting bar back here. And then finally, we're going to convert that hash table back to a JSON string to give back to Ansible. So if I was to run that again, but I also add a 1 to the end of that argument, we'll be able to see that the test key that's been returned now has bar 1 on the end there. So you can see how we're influencing the actual module as it's actually running. So that's the old way of doing things. We have gone a bit further to make it a lot easier to be able to get that input data and manage that with a few different options like setting type conversions, options around what things are mandatory and other things like that. We have the concept of Ansible Basic and the Ansible module inside that. Essentially, we define this comment string at the top here. So Ansible requires C# util and then the name of the util that we're actually using. So in this case here, Ansible Basic is something that's provided by Ansible itself. We define the module specifications. This is just a hash table. In this case here, we just have the options key, which defines the options that we actually can use for this one here. We're defining a foo option. We're setting the type of that option to an int. So we're making sure that when this option comes in, it is an actual integer. We're also saying that it's going to be required. So if it's not set, it's going to fail for us. We create our module and just setting it to a module variable here. Then finally, what we're doing is we're setting the return result. So the module object has a return property, which is a hash table or a dictionary, where we can set those keys to whatever we want. In this case here, we're setting the value of test, once again, to the value of the foo property, the foo option that comes in. We're also going to see, okay, if the input is set to 3, we want to fail this module. That's not a valid value that we want to do on there. To do that, we call module.failJSON, and then we provide an error string that's on there. So this will make sure that the module will tell Ansible that it has failed, and things will fail on the other end. Otherwise, we're just going to call exit.json, which is saying everything's all good, let's return our data back to Ansible itself. So we'll give you a brief example of that one there. So once again, same commands, but in this case here, we're setting the foo option to an integer, so this is just set to 1. We can see that test comes back with the value of 1. We can set it to 2, and we'll see that this one here has changed. And then if we set it to 3, instead of the green text and the success message that we get back here, we'll get a red text with the fail, and then the message that we have as part of our fail JSON call. So that illustrates that these failures are coming back to Ansible. If I was to set it to a value that cannot be in an integer, so I'm just going to set this one here to invalid, which cannot be casted to an int, we also get the failure. So we get that sort of automatic type handling and sort of conversion for us as part of that module argument specification. Just like PowerShell, we try to be a bit more lax in terms of what we will actually convert to those types. So like, for example, booleans can be explicit true or false values, but we'll also convert the strings true, false to true and false. So things like yes and no, 1 and 0, and so on. So some of the more complex options that we have available to the modules themselves. So if I open up 4 options, we can see that this script here has a whole bunch of extra options defined. So we have one called aliases, and inside that one there, we set the value aliases to a list of strings. What this means is that I can set this option using the aliases key, but I can also set it to alias 1, alias 2, and so on, whatever's defined on there. Typically, we do want to try and avoid them as much as possible, because it does make the UX and people new to the modules, it's a bit harder to understand, but it's good if you need to preserve backwards compatibility, or if you need to align some of the different behaviors to like a standard that you've recently set in a module. We have a way of setting explicit choices, so validate set inside an actual module. And once again, this is a list or an array of string values. If someone sets choices to something that isn't foo or bar, it's going to fail. Default, fairly self-explanatory. If no one sets this value, it's going to be set to that default value in there. No log. When we run these modules with a higher verbosity, so 3 or more, the return value is going to return to us the invocation data. So this will return all the input options that we've supplied to the module, which can be an issue if you're providing a password or a token or a sensitive value for that one there. When you set no log to true for this one here, that invocation data is going to be sanitized and set to a value that you can't actually reverse for that one there. So it's useful if you're using secure values like passwords. Required, we saw before, it needs to be set or else the module will fail. We have a few extra ones that are sort of just needed for this module to work here. But we've been talking about options that are specific to the option itself. You can also add validation behavior around how these options work together. So we have one called mutually exclusive, which means that any of the values in this array here cannot be set at the same time. It's a bit weird in terms of the UX around it and how we've defined it. This is sort of a copy of how the Python modules work, but due to array unrolling and other things like that, you do need to have that unary comma operator on there to ensure that there's an actual array. Basically, you can have multiple entries inside this one here. Required by is a hash table where if the key option specified is set, then any of the options in those values must also be set. Required if is probably a bit more of a refined version of required by. Essentially, if the first value offered here is set to the value of the second one, any of these options inside that third array must also be set. This is very common to see when you have your state options, so state present or state absent. Essentially, if state present is set, you want to have, say, like an identifier or like a mandatory key for that particular resource be set as well. Required one of means that you need to set at least one of these options. And then finally, required together means that all these options need to be set if at least one of them is. It's very common to see if you have a username password option on there, because if you have a username, then you're going to need the actual password itself. From there, we just have sort of the normal options that we have where we're just going to output. So I'm going to run a playbook this time. So if I run this one here, I can open up our playbook. We can see here that it's just a simple YAML file. We're defining the module that we're running as the actual key, and then indented inside that one there are the various options. So we have our aliases, choices, no log, and all the various sort of module options that we have here. Because we ran this with a verbosity of 3 or higher, we get that module invocation coming out here, and we can see that our no log value isn't actually in that output. So that's an example of how no log works to ensure that you don't get that secret exposure from there. It's not a foolproof value. You want to make sure you don't actually return that value somewhere else inside the module. It's purely for that module arg invocation to make sure that's not exposed in that output. The final option before we actually get started with writing this module here are the various option types. So I've briefly spoken about int and boolean. Essentially, the type key inside this option that you set, that will ensure that the value is casted to that type from Ansible. We've got a whole bunch of different types, and I'll briefly go over them. So bool, self-explanatory, gives you a boolean. Dictionary is a free-form key-value pair, so you can specify whatever keys and values that you want for that one there. When you also do a dictionary with the option subkey on there, you can now restrict and define your own argument spec inside that dictionary. So in this case here, this dictionary can have the int or bool key with the relevant casts that are happening on there. Float, a decimal value. Integer, integer. JSON is a bit weird. It's probably not really used. I actually haven't used it before except for this demo. If you provide a dictionary value, it's going to automatically cast that to a JSON string. So it's a bit useless because you can do that in your module code, but it's there if you want to use it. List is an array or a list of values. Without an element subkey, it's just freeform. It can be whatever you want. If you specify elements, once again, it's going to cast each of those ones in there. So in this case here, it's going to cast each of those elements to an integer. You can also do a list of dictionaries where you have a list of dictionaries with their specific types. So you can swap and change as you go along. That nesting of options is theoretically unlimited, but when you're developing your own modules, you probably want to only keep it to one level only, because it can get very tricky for people to use your module when you get that sort of nested depths. Path is also a string, but it's going to automatically expand environment variables using that sort of CMD syntax. So when you have your percentage signs on either side to the full string. Raw is raw, no type. It's not going to do any casting. SID is a security identifier. So if you specify a username, it's going to convert that to the security identifier object. You can also specify the SID as a string and it will handle that for you. Once again, quite rare. You probably won't use it, but it's there. And then finally, we have our string type. So we'll run this next example where we're setting a whole bunch of options and we can see how they're all actually converted. So we see that our module args has all that information here. We've got things like the list has been converted. We've got our integers. Our JSON is a JSON string. The path is now the full path, and the SID identifier is a SID. I also forgot to show you the playbook that we're running. So you can see that in some of these examples, the JSON, we've provided a string, a dictionary, but it's been converted. And then like say, for example, the path one, we do the system32 as an environment variable. That's been automatically expanded to C Windows system32. So that's a long-winded explanation around how you can do these modules and sort of the various options that are available to you. Let's actually get into it and write our modules and deal with all that type of stuff. So I briefly mentioned that we're going to be working with PS Resource Get. Specifically, we're going to be writing a module that's allowing you to define custom repositories. We're going to keep it quite simple, but it'll deal with the item potency aspect and a whole bunch of other stuff on there. So the first thing that we want to do is we want to take a copy of this sort of very basic structure that we have in modules. This is sort of a template, so 6_module. We copy it, we'll paste it back in, and then we want to rename that to PS repository. So we now have a module that we can call using the PS repository instance. The first thing that we want to do is we want to define the options for this one here. So I don't know, can anybody tell me what option you think would be required when we're defining a repository? Which one, sorry? The URL. Yes, that's one. There's another one as well. Yes, you can. In this case here, we're not going to go into that one there, but that's a good option there. The one that we need to set is the name of the repository, so how this is actually being called. So in our options subkey, we want to set name as the key. We want to set the type as a string, and then we want to make that required. So required true. When we're managing repositories, we have two states that we want to deal with. We want to deal with the state when we want a repository to exist, and we want a state where the repository doesn't. In Ansible, we typically use the state option with the absent and present values for that one there. So that's a standard or a common pattern that we see. So in this case here, we'll define state. We'll do the type is string. The choices is absent or present. And then we'll finally set a default to present. You don't have to set a default, but I find the most common case you see is people wanting to create this resource. So it's very simple to just sort of set that default so that they don't have to keep repeating themselves. Finally, as we mentioned before, we need the URL for this repository here. So we want to set URL type is a string. We don't want to set this one here to required, because if we're doing state absent, we don't actually need the URL for that one there. So we only want to set it when it is required. So that's when we get into that sort of special key where we can do our required if. We do our unary comma. We want to require it when state is equal to present, and then the option itself that is required is URL. So we've got our argument spec that's in there. That's fairly basic. You can add more as you're going along, things like the credentials, trusted. We won't be going into that one today because we just want to keep this sort of simple as we're going along, but you can define whatever you would like on there. From there, we need to be able to get those values back from the module object. This case here, I typically like to just define it as their own variables, but you don't have to if you don't want to. So we want to define name is equal to module.params, and then the option name. So in this case here, it's name. Then we'll repeat that for state. And then finally, repeat it for URL. So the params property that we have on this module object is a dictionary. It's set to the already casted value and validated values of our input ones based on our argument specifications. So now that we've got our entry point defined, we need to actually do the work of managing this resource. Typically, when I write modules, it's not a hard and fast rule. You don't have to follow it if you don't want to. But in this case here, we want to define the stage where we get the existing information. So in this case here, we want to set a repository variable. We want to run the get PS resource repository. And then we want to get a specific repository itself. Finally, because we need to deal with the state when there's no repository that actually exists, we need to set error action to either ignore or silently continue. So we're getting our state from there. So now we have our various states that we need to work with. So we need to deal with when state is absent and the repository exists. we need to still deal with when this repository does exist, but a value isn't set to what we want. And then finally, we need to deal when the repository doesn't exist, but we want it to. So the way I typically do that is I deal with absent first, because it is very easy. So we do when state equals absent. And then finally, we do if repository. So the repository does exist, which is great. We want to unregister that PS resource repository. Name is name. And there we go. Because we've made a change, we now need to tell Ansible that a change has actually occurred. To do that, we simply set the change return value to true. So if you go module.result, which is a dictionary or a hash table, and then finally we set the change key equal to true. So we're already 1/3 of our way there. We've done state absent. So now we need to deal with state present. So we'll add an else, because we've only got the 2 states based on our choices. I want to deal with when the repository exists and we want to check whether a change needs to occur. So say the URL is set to something different. I could just do if repository.url is not equal to the URL that we have on here. But in terms of further expansion and some later stages in this demo here, I'm going to do something a bit differently. I'm going to create a hash table, so change params. I'm then going to check, okay, does the repository in this case here, it's actually the URI, not URL, is not equal to our URL. I want to go changed params.uri is set to our new one. And then finally, I want to check if, okay, have we detected any changes? And then if we have, we want to go to set PS resource repository, set the name of the repository, and then splat our changed params. So that enables us in the future for adding things like the trust option that we want to set or credentials or things like that. That allows us to sort of easily iterate through those checks and then do that final, okay, was there an actual change? Make that change type of action. Once again, we also need to set module.result.changed equals true. And now we've dealt with the second state. The third and final one is when the repository doesn't exist, but we want it to. And that's literally as simple as else register PS resource repository. We want to register the name and the URI to our URL value. Then finally, I'm sure you all know, we want to tell Ansible that a change has occurred. That's it. We've got a very basic module that can deal with registering repositories, unregistering them, as well as sort of making sure that the URL that we've defined is actually correct. So let's see this in action and let's see it actually running. So I'll scroll down here, skipping over sort of the things that I've sort of talked about. We can see that if we define no module options for this one here, so we're just calling this playbook, it's going to fail because I have got a syntax error in there. So let's go to line 14 and fix that one up. What did I do? That's correct. That is correct. Sorry, what was that? Which line was that? Sorry, I can't really hear. There's a comma. Thank you very much. And another one that I've done. This one here. So no, the comma's there on purpose because I'm creating an array of values. So I'm setting choices to both absent and present. I could use the actual array literal as well. In this case here, I'm just not. So let's clear that out and let's run it again. So fantastic. We've got a failure and we've got a message saying that the name has to actually be set. So we can see as we go along there, that's what's actually going to happen. We can also repeat it when we're setting name and state, but we're also not setting the URL. We can see that it's failed because state is present, but the URL isn't in there. So there's we can see that our sort of module options and the validations all happening on there. So let's actually test how this works when we're setting the various ones. So in this first example here, we're going to be setting name to PSConfEU, and we're going to be setting the URL to foo.com. So if we were to run this one here, we'll see as this one runs, it's going to output with some yellow text and say changed and changed true. So that's telling us a change has occurred. If we were to rerun this one again, if I've actually written this correctly, it should just say success and there's no change that's on there. So that's Ansible telling us that I ran this one here, nothing actually had to happen. So we have that item potency. We can then enumerate the various repositories that we have on there. So we're just checking for PSConfEU. And why does that, it doesn't work because I didn't define playbook dir. That's what I get for not testing these demos too thoroughly. So we can see that we're just going to run the WinPowerShell module, which is running freeform PowerShell scripts. We can see that we have our PSConfEU repository defined, and it's set to the foo variable on there. So the next step that we want to do is we want to test to see that if we're changing the URL, in this case here, we're changing it to bar.com, it will report that a change has occurred. If we run it again, we'll see that, hopefully we'll see that it's success with no change. And then finally, if we rerun our WinPowerShell one to get that information, so the existing state, we'll be able to see that the URL has been set to foo. Sorry, we originally set it to foo, now we've set it to bar, so it's set to bar.com. Finally, the last one that we have here, we want to test when the state is absent. So in this case here, it's going to remove that registration. Finally, we'll run it again to make sure that our item potency checks are all correct. Should come up with success with no change. And then we're going to fix up my mistake. And then we're just going to check to see if there's any resources registered under that one there. And we'll see that we've got no output objects, so the resource no longer exists. So we've written our module, we've checked that it works, we've also verified that we can make changes and do things idempotently. So say you have a module that you need to debug a problem that's on there, or if you just want to develop one and you don't want to deal with this, run Ansible, get the results back and sort of deal with that. If you want to debug values as it's actually run, there is a way of doing that. I'm in the process of sort of writing a helper script or a helper module for it. Fortunately, it wasn't ready in time for this presentation here, so I need to get on that one a bit more, but I'll show you how it can be done manually. So in this case, we have a module, which is the PS repository debug. I've put in a known error on this one here, so I know what's actually wrong. This is going to create a repository and set it to foo.com. If I was to rerun this one here, we'll actually see that it has reported another change again. So changed equals true. So that tells us that we've got a bug. It no longer has that item potency on it. I could go through that code and try and figure out what it is by looking at it. But in this case here, I want to actually step through the code to see what it's doing as it's actually running. So in this case here, we want to open up PowerShell. We want to run a specific script that will set everything up for us. So in this case here, I want to go to our D drive. This is just sort of a scratch drive. And I'm just going to copy and paste this one here. So what this script is doing is it's going to download the latest Ansible checkout from GitHub. It's just going to download it as a zip because I didn't want to deal with the Git slowness that can come with that one there. It's going to expand that Ansible archive inside that PSConfEU directory that enables us to be able to deal with all the various module utilities that the built-in runner that's being used, as well as use that runner itself to replicate roughly how Ansible runs it. This checkout here has a lot of files on there, so it might take a few minutes or so. So I'll briefly get everything else ready for us. We want to create a new window in VS, not that one there. We want to create a new window in VS Code. Let's make this a bit bigger. We want to open the folder. So we want to go, in this case here, to our D drive. Then we want to open up PSConfEU. So we can see that there's some files that are sort of being unpacked as we go along here, but we'll select that folder. We'll do some stuff in the background. And then we can see that our script should be finished. Hopefully yours is as well if you're following along. So in this case, let's open up I trust the author. We can see that this Ansible folder here has the actual Ansible Git repository checkout. It's only a few files that we need, but we just got the whole thing. But for the sake of it, we have our run.ps1 script. So this is a whole bunch of PowerShell code. Let's make this a bit smaller, sorry. PowerShell code to sort of get everything up and running and to run it in the same context as Ansible. And then finally, we've also created a VS Code launch configuration. So what this does is it sort of just runs our module when we try and debug it inside that runner itself. So now that we've got that one there, we'll create a copy of our known buggy one. So 7 PS repository debug. We'll create a copy of that. We'll create the file here. We'll call it PS repository.ps1. Paste that one in there, and we've got our code. We also want to create a corresponding JSON file with the same name. So PS repository.json. If I go back into our README, we'll see that we've got the example one here. So the reason that we're using JSON is that we're using this to provide the arguments as Ansible would as well. You could define it as a hash table, but this ensures that things like list types and hash tables and other stuff like that are properly deserialized as it would run in real life. So we'll copy that string here, we'll go into our JSON, we'll paste that one in there, we'll close that, and then finally, we're just going to set a breakpoint on this one here. So if I press F5, just like you normally would for a PowerShell script, it's going to go through that runner, initialize PowerShell, and hopefully in a few seconds, we're going to stop on that breakpoint here. So we can see that, okay, yes, the name is coming through correctly. We have PSConfEU. We have the URL set to foo.com based on our JSON one. So we know that the data is coming through as expected and everything is all good. So let's step through the code itself. So I had this problem here. I'm just going to run it once. So we know that it has changed and the repository has been registered. If I click on next, we can see that we have a repository object. So PSConfEU, the URL is set to foo.com, which is based same as what we have here. And then now we can step through the code to try and see what is going wrong. So the state is correct. It knows that a repository is there. It's checking if the URL matches. Wait, it does match. So why is it going through this one here? I don't know if it's a bit too small, but can anybody pick up why that might be the case? Sorry? Yes. So in this case here, I'm checking repository.url. If I look at my object itself, I can see it's repository.uri. There's our bug. We're checking something that doesn't exist, so it's never going to match, and that's not good. So we'll continue the script. We'll fix up our typo. We'll then rerun this again. As we're stepping through the code, it's getting to the same spot as it did before. Okay, so it's picked up that there wasn't a change, which is great. That's what we expect. There's no change, and now it's going to continue on and exit that script. And we have change false and our invocation arguments. So we can see that we've been able to debug our module interactively, see the value of modules, see what the objects look like, and figure out why that one was wrong. So that's a very basic example of how you can actually debug these things. You can take it a bit further when you're building your modules and doing a bit more complex things that might require this one here. Okay. So we've built our module. We've sort of done some basic tests that everything is working correctly and everything is all good. What are the next steps? So the first thing that we want to look at is what we call check mode and diff output. Check mode is very similar to PowerShell's what if operation. So it's essentially, is a change going to be made? report that change, but don't actually make that change itself. So it's useful if you're seeing, okay, do I need to do something, but not actually do it? Diff output is sort of a more in-depth output that allows you to detect what actually changed. So instead of the module reporting that a change has occurred, we can see exactly, okay, this property has changed, or it was removed, or something like that. Check mode is very important to support. We try and make sure that all the modules that we develop have check mode. Some things can't do it just by the nature of them, like running a command. But diff mode is more of a typically nice to have. It's not mandatory, not everybody does it, and it can make your code a bit more complex. So let's go back to our module and let's look at adding in check mode for it. So the first thing that we need to do, well, let's have a look at what happens when we run this module in check mode. So to do that, we're just going to run the same thing. Actually, no, we want to remove that repository that we were testing before. So once that's been removed, we want to rerun creating it. But in this case here, we're going to be adding this --check argument to the command line. So that's passing to Ansible to tell it, run this module in check mode, don't actually make changes. We can see here we have blue text, which is new. This one here is telling us that we skipped running it. We did that because the module doesn't declare that it supports check mode, so it should run in check mode. So similar to PowerShell functions and commandlets, you need to explicitly add an identifier to the module to say, yes, I support check mode. I can actually run in this operation here. So we'll go back to our module and we'll do just that. So to do that, essentially we get to our module specifications. Same with required if and options. It's just a new option on there. We have supports check mode is equal to true. So now if we were to run this one here, it's not going to skip, but we haven't done anything else to actually implement check mode. So we need to do a few things to actually make sure that we detect the change, but don't actually perform that change when we're running in check mode. Typically, with PowerShell or with PowerShell commandlets, they have a what if parameter, so they support that themselves. The easiest thing to do is just add what if based on the value of the Ansible check mode status. If a function or a commandlet, or you're calling a .NET method or doing anything else really, you can just wrap it in an if statement. So you can say if module.checkMode and then skip that. Or if it's not check mode, run that particular operation. Luckily for us, these commandlets do support what if, so we're just going to do that one there. So there's 3 locations where we're actually making a change. We're removing the repository with unregister, we're changing the values with set, and then we're registering it if it doesn't exist here. So we're just going to add -what if to the value of check mode. So if check mode is true, we're running in that one there. We want to actually specify what if. This syntax here, I'm not sure if you have seen it before. It's just a way of explicitly providing a value to a switch parameter. So this case here, we're setting it to true. You can set it to false and it will act the same as the switch isn't actually there. So we'll go to the next one. So set PS resource repository. We want to add what if module.check mode. And then finally register, once again, simple, what if module.check mode. So we've done it. We've added check mode support and we've made sure that the changes that we made on there won't actually run in check mode. So if we were to rerun that same command from before with --check, we'll be able to see that a change has been reported. And if we actually run the same command to get that information, let's just skip past everything here. I need to update my examples to include this. So we're going to get that PS resource repository under PSConfEU, and we'll see that there is no output, no resource was actually registered. So we know that check mode has actually worked. We can test the same thing as well with like removing it or setting it, but it's pretty much the same thing anyway. So we're just going to skip over that because everything's all sort of hunky-dory there. So we've got check mode. The next one is diff output. So diff, like check mode, is enabled by specifying --diff to the argument. If you don't support diff mode, it just does nothing. Nothing's actually returned. The way that we support diff mode is by adding in 2 values to our diff property on our module object. So in this case here, what I usually like to do is I like to define the before and after state right at the beginning. So I go module.diff.before. I'm going to set that to null. I'm also going to set the after state to null as well. Null in sort of diff terms means that the object doesn't exist. So in this case here, I'm saying that before and after the object didn't exist. And later on in the code, as I'm going along there, I'm going to set that based on the actual state that we have. So the first thing that we do is we actually want to set before if the repository does exist. So it's very simple. I'll check if the repository is set. And then if it is, I want to go diff.before. I set the value to a hash table or a dictionary. And then I'm going to set the options that's relevant to us. In this case here, it's just going to match the options of our module argument spec. So we'll set to name is set to the repository.name. Then the URL is set to repository dot, well, it's URI in this case here. So we've got our before defined. I find you can add more objects on there, but it's really great to just follow along with what your actual module argument spec is, because that allows people to see, okay, if I set this option here to this value, this is what's going to change. So it's good to keep the diff output aligned with your actual module options. So the first case that we need to deal with is when it's state absent. In this case here, we have to do nothing because after is set to null, and when state is absent, there's going to be no resource. So we can skip over that. There's no extra work that's being needed. We do need to deal with when the repository does exist, but a potential change has occurred. To do that, we go module.diff.after. I'm going to make a clone of the before value. So it's going to be an exact copy of what was before, but every time we make a change, I'm going to go module.diff.after.url is equal to our new URL value. So you can see how that pattern where I'm using that hash table sort of comes into play here, where we're able to sort of easily add options for diff support, as well as future options as we go along, rather than dealing, okay, has this changed, make the change, has that changed, make the change. We can all do it in one go. Finally, the last state that we need to deal with is when we're creating the actual repository. So there's no diff before that we can actually copy. So we just need to create the new object for after. So module.diff.after. Oh, I'm using squares. We want braces. We'll set the name to the name and then the URL to the URL. So that's it for diff mode. So this is a fairly simple option to deal with. If you're making your own, yours might be a bit more complex. But you can see here, it's basically fairly simple. You define a hash table with your before state, you define a hash table for your after state, and you use null if it doesn't exist at all, depending on those two particular states. So let's see diff mode in action. If I scroll down to the commands that we're wanting to run, so you can see here that we're going to be creating a resource with the URL set to foo.com. We're also going to be adding the --diff, so we'll run in the diff output. So when this here returns its results, let's make this a bit bigger so it's easy to see. So we have our command that's running at the top here. We can see that we have this diff output that's before our host return result. So each task that has reported a change or a diff, we can see that there was no before, so there's no red text that has been changed, and we have our green text after that to show us what has actually changed. This is in scope of how sort of the git diff output works, and you'll be able to see in the subsequent test how that looks if like an individual object has actually changed. So in this case, we're going to be running the same thing again, but we're going to be setting the URL to bar.com. So you'll see as this one here comes up, we can see that the old URL, so it's now in red because that's the before state, and finally it's been changed to that new state, which is bar.com. Then finally, when we're wanting to remove the repository, we can see what that actually looks like. We'll be able to see that all the text is in red because it's removed the whole repository. So there's nothing that's actually been changed to a new value. We've gotten rid of it all. So we've created a module with check mode and diff mode. what's the next step? Next step is documentation, which is very, very important. Essentially, it allows people who are using your module to be able to know, okay, how do I actually use this? What do the options offer? How do I actually use those options? How can I define this type of stuff? Inside Ansible, modules are written as YAML strings. I'll briefly show you in the demo how that actually looks like. And we have 3 fields inside that documentation. We have the documentation section, which defines the options, their types, descriptions. We have examples, which will give people examples of how to actually use this in common use cases. And then finally, we have return info, which for our example, we don't have, but that allows you to define what does this module option return as options that you can use going forward. We do also have tests to make sure that what is in your documentation also aligns with your module itself. So there's a whole bunch of things that you can use to validate to make sure your documentation is all correct. So let's go back to our module here. We want to create our docs. If I scroll down, I'll show you what happens if your module doesn't have documentation. We'll see that this here fails. There's no documentation found for our module, so our PS3 repository module. So what we want to do is we want to take a copy of this 9module.yaml. So this is once again a scaffold that we'll use to build our documentation. So Control-C, Control-V. And then what we want to do is we want to rename it to the same name as our module. So we have psrepository.ps1. We now have the corresponding psrepository.yaml. In the past, you did need to use a Python file to embed your documentation, but in Ansible 2.15, we can now use YAML directly alongside that file itself. So that gives you a few niceties like syntax checking and other things like that. So in the actual docs itself, I was mentioning we have our documentation section, we have our example section and returns. In this case here, returns is just going to be kept as an empty dictionary, because we're not actually returning any specific options outside of that changed, which is a normal one expected in Ansible. So we'll define our repository. So PS repository is a module name. The description is just a very basic sentence. So manages PS resource and get repositories. The description is a bit more in depth. So more info about this module. I won't bore you with some of the details. And then finally, we define the options for this one here. So we have our name option. We set the description to the name of your resource to manage. It is required. And then the type is a string. We have our state option. Create or remove the repository. We have our choices now, so we need to define absent or present. It also has a default of present. And then finally, we have URL, which is set to the URL of the repository to set. And then it's type string. I also forgot to put type string on this one here. So we have our options defined in our documentation. We can get rid of this scaffolding that we have on here. And then finally, the author. What we typically do is we use our name or the name that we go by. And then if we have a GitHub handle, we add our GitHub handle, GitLab, whatever, inside the brackets on there. So we have our documentation set. Now we need to provide some examples for this particular module. So we need an example to create a repository. And then we have PowerShell.conf, PS repository, PSConfEU, URL is set to foo.com. Then we just want an example of how to remove a repository. ConfEU, then state absent. Depending on your module, you may have more examples. Typically, as you add those options, you add an example that uses that option to tell people how to do it. This is a very, very basic example, so we don't have to go really too in-depth inside that one there. So if I clear the screen and I rerun that Ansible doc command, all options have a description. Obviously, I must have had a typo. I put name. Thank you very much. Did I do that for any of the other ones? Thank you. Cool. So we have our documentation here. So we see we have our description, the options that we define, the description and the types, the state with the choices, and then we have our examples on the bottom one there. Ansible itself actually derives our online documentation based on this string here. If you're part of sort of that built-in distribution or sort of that collection that we have, it will automatically do it for you. We also have tools that can generate some HTML pages for that one there. That just sort of shows how it works inside the Ansible doc command. Last thing is testing. Testing is super important when you're creating code. It allows you to ensure that you're not making any mistakes. So any assumptions that you made will be challenged to make sure that they were correct. It is also super useful when you're dealing with future operations and future additions that you're actually adding on there. All the testing inside Ansible collections is done through the Ansible test command. This is part of the Ansible distribution like Ansible Doc, Ansible Playbook, and so on. For Windows, we have a whole bunch of options. So we have ways of running sanity tests, so making sure that the module documentation aligns. The scripts are aligning to the PSScript analyzer rules that we have set up. The integration tests are actually Ansible tasks that are written to run our module and run specific tests for it. And I'll show you some examples of that one on there. So we'll go through an example of actual tests itself. I can't run the sanity test on this one here because it'll actually pull down a few dependencies, which can sort of be quite heavy for the internet. But I'll give you an example of how to actually run that one. So in this case here, we have our Ansible test commands. We have the subcommand, which is sanity. So it's running sanity tests. And then we're supplying specific tests that we want to run. In this case here, pslint is linting for PowerShell. We're using PSScript analyzer with a few rules that we've defined. Validate modules will ensure that your modules align with various argument specifications that we have. So it does have a specification, choices are set correctly, all that type of stuff. Then Ansible Doc will ensure that your documentation for the modules aligns with your module itself, as well as ensuring it is valid, so I don't have that silly mistake where I set name instead of description. But I won't show you that one running because, as I said, it will download a few dependencies which we don't actually need. So what we want to do when we're running integration tests is that we want to make a copy of our inventory that we've been using to run these ad hoc commands, and we want to place this in a specific directory. So inside the collection itself, we have our tests integration folder, and then we want to create a file called inventory.winrm. So that's a file that's specifically looked at by Ansible tests to see how do I run these tests on which particular hosts. We're just creating a copy of what we're running with here, so it's just going to run on localhost itself. You can do multiple targets if you want, but that might potentially slow things down because it runs sort of each step on each host before moving on to the next one. When we're running the tests, we do need to be in the actual collection repository or root directory. So I'm going to change to that collection directory itself. So if I go ls, I can see that I'm in that plugins and tests and the galaxy.yaml, which is like the metadata or manifest of a module. I'm then going to run Ansible test with this Windows integration, and then I'm going to set a test target. So if I was to open up my tests and integration folder, I can see that I have my inventory that I copied across. If I was to look into this one here, I can see that the host and the connection variables are defined. And then finally, if I look in the targets, I see I have a PS repository folder, and then it has the various tasks that we're running. So I'm going to kick this one off here because it will take probably a minute to actually run as it's running in the background. We'll go into that test itself to see what it's actually doing. So the first entry point is this main.yaml. In this case here, we're doing a few steps. We're basically removing any test data that may have been left over from previous runs to ensure that we've got a clean run, that nothing that's run before will actually impact it. We'll run our tests inside the test.yaml file. So that's a whole bunch of Ansible tasks that it's running through right now. And then finally, at the end, it's going to remove any test data that may still be there after a potential failure. So that's sort of just like a quick before cleanup and after that you usually see inside the pest test that you have. Inside the test file itself, we have a very common pattern that we try and work with. You're not restricted to doing it. You can do whatever you like. But typically we have a scenario that we want to test. We first run it in check mode. So we can see here that we've added the check mode option to that task. We get the result after that particular run. And then we verify that the check mode reported a change, but there was no actual change that occurred. We then repeat that same task without check mode. We get the actual results. And then finally, we make sure that a change was reported. And then also the name and the URL is set correctly to what we expect. Finally, we do it one more time for an idempotent check. So we run the same step again. We don't have to get the results because we don't really care about that. We're just verifying that a change has not been reported. In this case here, the test is doing the same thing for setting a value. So it's running in check mode, doing it for real, and then an idempotency check, and then finally removing that, doing it for real, and so on. So you can see here that the output, everything was okay. There was no failures and everything was working all great on that one there. So our tests are good and it has verified that what we have in our module does actually work and everything is great. As you're going along, this will expand as you're adding new options, but you can keep on running this as you're making changes to your module and trying out new things. So tests are super invaluable. I highly recommend them. Unfortunately, they probably take about 60% of your development time. So it's a big investment, but they really pay off when you're managing or maintaining these modules. So I know I'm getting quite close to the actual time itself, so I won't go too in depth into the next part here. So we've created a module. What's next? What can you do beyond modules themselves? We have a concept called action plugins in Ansible. They're essentially a step higher or an extra layer above modules themselves. They're executed on the Ansible host itself, so not your remote target. But what they can do a lot more things that modules cannot. So you can run multiple modules instead of one. When you don't even have to run a module if you don't want to. You can access the host of variables that might be set from previous tasks that, whereas a module might need them provided as explicit options. The downside is that they do need to be written in Python. So if you're not familiar with Python, it's probably not too useful, but it has that ability for it. Some very common examples of action plugins are our WinCopy one, which allows us to copy files to the remote host from the Ansible controller. WinReboot, which can actually reboot the host after a task has been run, is also an action plugin because it needs to manage when the connection goes down, as well as WinFetch when we're getting a file from the remote host and getting that one back there. So I'll give you a brief example of an action plugin. So instead of the modules directory, we now have this action directory, and our action plugin is called SMB copy. So there's a whole bunch of Python code that we have on here where we're importing various things, we're setting options. I won't go too in depth inside this one here, but just a brief example. We can see that this one here is executing the WinStat module, and then it's also once again at the bottom going to be executing the WinCopy module. So this is an example of where it's going to be doing multiple modules inside the same plugin. So you can do more complex examples for that one there. When you're calling an action plugin, if I go to my example playbook, you can see here that it looks exactly the same as a module. So you specify it in the same name where you have the action plugin name, so SMB copy, and you set your options as expected. So if I was to run this one here, so I type in the module name. Nope, I need to go back down to that directory. So if I was to run this one here, what this is doing is it's actually going to be copy this exact playbook file over the SMB file share rather than through actual connection plugin, WinRM is pretty notorious in terms of its very slow file copies. It doesn't actually have a file copy mechanism, so it needs to smuggle that data as part of commands, which is very inefficient. It's not very fast at all. This case here, this is just an example of how you can use an action plugin to overcome that issue by using like SMB as a file transfer instead of using the connection plugin itself. So we've copied the file. We can see that a change has occurred. If we open up our other VS Code window, we open up the File Explorer, we can now see that there's a test.yaml file on there. If I was to rerun this one here, it will show up that there's no change has been reported. So no change, it's been okay, and the file is still there. If I was to make a manual change to this file, so just getting rid of that end new line and rerun it again, we'll see that a change has been detected. It has run, and if we go to our file itself, we can see that that new line is no longer present and it has been updated. So we can see there that with action plugins, you have more options, but it is a bit of more of an advanced topic. It's just something that you sort of keep in the back of the mind as potential options for the future. So the final thing that I wanted to share with you is module utils. So module utils essentially is a way of sharing common code across multiple modules. In Python land, they're written in Python. There's just sort of normal Python code. For PowerShell modules, we can write them both as a PowerShell module file, but we can also write them as a C# file itself. So if you need to do more advanced things like p-invoke definitions, or you have a very tight loop that needs to be a bit more performant than what you can achieve in PowerShell, you can do that inside a C# module util. So a very, very brief example of that one there. So we'll go to our repository again. We'll open up a final module here called 12 module utils. Let's close down some of the other ones. We can see at the top here, we have our Ansible basic that we saw from before, but then we have two new lines here where there's C# util referencing module utils C#, and then also module utils PowerShell for a PowerShell one here. We can see that in this collection, we have a module utils folder. We also have a C# and PowerShell. So that's essentially what that line is referencing. Because this is all built around the Python import system, it has a bit of a Python flavor to it, which is why there's dots, and that sort of path works the same way. But it's essentially saying, load these files inside the module when it runs, and I can reference it in the playbook. So in the PowerShell one, we just have a very simple function called get PowerShell module info, returning a string. And then in the C# one, we have a very similar thing where it has a sort of standard class with a static method returning a string. Once again, because it uses that Python system, we do have a few sort of, not limitations, but maybe some downsides in the UX. The namespace is quite long, so this needs to match up with that Python namespace that we're expecting, just to avoid any potential collisions in the future. We have the ability to define custom type accelerators to sort of make a shortcut to that name. So instead of Ansible collections, PowerShell conference, yada, 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 we can reference it using this type accelerator that this will actually create. If we look in our module itself, we can see that we're calling get PowerShell module info, just like a normal function. And then for the C# one, we're just calling it like the static method it is. You can do C# classes and instances, whatever you would like with that one there. So it's really not limited with what you want to do. You can do whatever you like. So if I was just to show you that one actually running, there's a whole bunch of more information that I won't really go into. So we're going to call that module, which is referencing that C# and PowerShell util, and we can see that we get that C# data back and that PowerShell data back. So if you have very common code that's repeated a lot of times, that's when it's great to be able to use that as part of a module util, so you can sort of remove some of that sort of shared code that's happening on there. And that's it. We've created a module. We've sort of done it from start to finish. I even showed you how to install Ansible and sort of get that up from scratch. Hopefully it wasn't too boring, and I hope you guys really enjoyed it. If you have any feedback, this is the first time I've done this presentation, and I've been thinking about actually creating a demo for our Red Hat side for customers and other people interested in it. There's not too much information around the Windows development side, and I'm really hoping to try and change that in the future. So if you have feedback, the app has a way of providing that feedback, or even just sending me a message. My email's everywhere, and you can try and chat with me as I'm around. That'll be fantastic. But if you have any questions, now is the best time to ask. I'm happy to answer them as best as I can, whether it is around something that I've demonstrated here, whether it's around Ansible, or whether it's just a question you want to ask me. I'm happy to answer whatever I have here. So you also need to speak up. My ears aren't the best, so I'll try my best to hear you, but we'll see how we go. Yep. So if I understand the question, it was about the future of running PowerShell module on the Linux side rather than just Windows. Is that correct? Cool. So it is theoretically possible today to do that. You can run PowerShell modules on Linux. It's a tiny bit different in terms of that shebang that you had at the top of the file. It would be like user bin Python rather than, user bin PowerShell rather than just the PowerShell side. But essentially you can do that. The downside is that you can't use those module utilities for that one there. So we've got plans of trying to make that a bit easier to share that code. It's not currently there, but it is definitely possible to run standalone modules in PowerShell right now. Cool. Thank you, Rob. Fantastic. Thank you.
Thank you. A silly question. If you want to manage Linux and Windows hosts, is it possible to do it in the same module, or would you have really to split it?
Sorry, are you able to repeat that one again? Sorry.
If you want to, let's say, you want to have the same result on a Windows or Linux host, I don't know, create files or whatsoever, is it possible to do it in the same module, or would you have to have separated modules?
Theoretically, it is possible to use it in the same module. The downside is that there's a very hard split between the Python and the PowerShell sides. They're very much hard-coded to be Linux, Mac OS versus Windows ones. Like as I was saying, you can do it if you run it in a PowerShell one that can run on both actual hosts itself. But theoretically, we keep them separate, mostly because you might have some common utilities between them, but we've found that Windows and Linux have a lot of opposing way that they actually work. So doing that as the same module makes it harder to document because you need to say, okay, I can use this option for Linux, but not Windows, and vice versa. So that's why we try and keep it separate.
Yeah, so if I understand correctly, it would be easier to have two separated modules, but handle that in the playbooks.
Yep.
Okay.
So
thank you.
You can also, theoretically, you can also name them the same. So you can have the same module with a .py or a .ps1. We typically avoid that because while it does work, it can have some side effects that's not fully tested yet. Well,
thank you.
Thank you very much. Cool. Once again, thank you very much for listening. I really hope it wasn't too boring or anything like that. I'd love to hear feedback on it. And thank you very much for coming. I really appreciate it. And hope you have a great conference as we go along. Cool.